What's up? Welcome back to Stuart Science. Got another one-take video for you here, so if I screw up, as long as I don't say a cuss word, we're going to keep this video rolling. So today we're talking about how to interpret a chemical formula. Now, some of this stuff is probably intuitive, but there's levels to this you probably haven't seen before in your other classes. So if I write H2O, you probably can figure out that means 2 hydrogen, 1 oxygen. So the subscript here goes with just the element in front of it. So this would be HHO. If I had you diagram this, that's a diagram. It's a drawing. 2 hydrogen, 1 oxygen. Or another easy example to start with would be CO2. You've heard it called carbon dioxide. CO2 would be COO. 2 oxygen, 1 carbon. Now, one thing to watch out for with this is that some element symbols are 2 letters. So if I put like Al2O3, that's ALALOOO. It's not, do not do this, but ALLOOO. Because this 2 goes with the whole element, which is Al. That is 1 element. So if you have an element that's 2 letters, don't forget you are duplicating the whole element, not just the second letter. That's not a thing. Or another common one is like Mg. So like Mg3s2. Mg3, 3s2. This is not MgGGSS. Wrong, false, bad, ooh, gross, no. It's MgSS. That is your diagram, because this 3 goes with the whole element, which is Mg, not G. So that's the first rule. Your subscript goes with the element in front of it. The second rule is that sometimes you can involve parentheses. And so the subscript outside the parentheses goes with everything inside. So I'll give you another easy example here. MgOH2. That 2 goes with the whole thing. So you write Mg and then OH twice. OH. Now, what I see a lot of students do is MgOOH. You can do that. That is not wrong. I like to keep it OHOH because then you can easily see this whole unit here, what's in the parentheses, copied twice. You can easily see that you have it right. If you have something bigger, so I'll do another one of these. ALPO4 3. I have that. That would be AL and then PO4 3 times, which I would write POOOO. 1 P, 4 O's, and that whole thing I copy and paste 3 times. POOOO. POOOO. It is not wrong to go AL, P, 3 P's, and then 12 O's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can do that. Nothing wrong with that. But again, what if you wrote 11 O's? Like, it's kind of hard to count that way. It's really easy to see 1, 2, 3. So you can kind of see this at work. Does that kind of make sense? Well, I guess you can't really answer that question. So if it's in the parentheses, that applies to the entire thing. There's only one more way I can make this slightly more challenging, and that's to pop out what's called a coefficient in front of it. So if I put like 4 Fe2O3. This right here is called a coefficient. It just means you make that many whole copies of the entire thing. So where the parentheses only apply to the stuff inside the parentheses, the coefficient applies to the entire thing. So this would be Fe, Fe. Don't get baited by that two-letter element. It's Fe. Iron is the element, not E. So it wouldn't be Fee. It'd be Fe. 2 irons. And then O, O, O. That's what one Fe2O3 would look like. But I need 4 of them. So I just need to copy and paste this whole thing 3 more times to get 4 total copies. Fe, Fe, O, O, O. Fe, Fe, O, O, O. Fe, Fe, O, O, O. Okay, my video is covering up part of it, but there's an O behind it that you can't see. So that would be 8 total irons and 12 total oxygens. So that's what the coefficient means. And then when we put all of these rules together, see if I can come up with one on the fly here. We put all these rules together. Try this. I think that's a real thing, but I might have got the formula wrong for silver nitrate. If you're into Googling things, don't fact check me on this. I'm just using an example of how to show these rules. So you can see here we have a coefficient by itself, so that only applies to the O. We have a coefficient on the outside of parentheses, so that applies to everything inside the parentheses. And then we have a coefficient out in front. I misspoke a second ago. This is called a subscript. That's called a subscript, not a coefficient. So let me recap that. We have a subscript that only applies to the O. We have a subscript that applies to everything inside the parentheses. And we have a coefficient there that applies to everything after it. So we have AgNO3 twice. That's what AgNO32 means. 2 NO3s, 1, 2, and then 1 Ag. And then our coefficient here tells us to copy the whole thing, so we have 3 copies. A, G, N, O, 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 N, O, 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 and copy and paste one more time. A, G, N, O, 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 N, O, O, O. And that's how we interpret chemical formulas. The subscript only applies to the element that it's after. So this is 3 O's. A subscript outside the parentheses tells you to make that many copies of whatever is inside the parentheses. And then a coefficient out in front tells you to make that many total copies of the whole thing. As always, this is Mr. Stewart. Keep learning no matter what.